Good morning, everyone. Welcome to Guru Brahma classes for JEE and NEET. In this session, we are going to learn about photoelectric effect from the chapter Atomic Structure. So, what is the topic today? Today, we are learning about photoelectric effect. So, in simple language, we can say that photo. So, what is photo? Photo means light and light. Electric already we know that it is electrical energy. That means light energy is converted into electrical energy. So nowadays we are seeing on homes we have photoelectric equipments where sunlight energy is converted into electrical energy. So this is the phenomena occurring in those equipments. So what is photoelectric effect? In the definition, if you see, it is the phenomena of ejection of electrons from the surface of a metal. So surface of a metal when light of suitable frequency strikes is photoelectric effect. Regarding definition, if you see, what is photoelectric effect? Here you can find some setup here. So in this discharge tube, there is nothing, no air inside it. So what is there? Vacuum. Vacuum means if there is nothing in this glass tube, nothing is present. That is called as what? Vacuum. No air is present. So in this evacuated discharge tube, what is taken? A metal is taken which is connected to negative terminal of the battery. So this metallic surface, so this metal is made of first group elements like rubidium, cesium, potassium or rubidium or cesium. Why we are taking these metals, alkali metals? Because they have less ionization energies. The valence electrons are weakly bonded. Nucleus cannot hold the outermost electrons effectively. If they lose one electron, they get octet configuration. So first group metals like potassium, rubidium, cesium are used in this photoelectric effect. Okay, because they have very less ionization enthalpies. They can lose electron easily. If they lose one electron, they get octet configuration. That is also one of the reasons why they have less ionization enthalpy. So in this setup, if you see, this metal which is made of first group is connected to negative terminal of the battery, and the other metal here, if you see, this is the metal. This metal is connected to this metal, can be any metal like zinc. This is connected to positive terminal of the battery. So between this metal and battery, there is an instrument called as ammeter, which shows or which deflects or which shows how much amount of the current is passing. By the deflection of this needle, we can observe how much amount of electricity flows in the circuit. This deflection also represents that whether the electricity is flowing through the circuit or not. When it gets deflected, then it shows that electricity is flowing through the circuit. If this is not deflected, then it shows that electricity is not flowing through the circuit. So this is the setup. So this setup is exposed to sunlight, light energy. For example, light energy. So light energy is the source where this light energy is converted into electrical energy. How this happens, let us see. So definition, ejection of electron. See, when this light is falling on the metal which has less ionization enthalpies, the valence electrons or the electrons mainly which are weakly bonded will eject from this metal, see, from the surface of the metal, and flow through in the circuit. So this light must possess a minimum frequency which will be helpful to eject the electron from the surface of the metal. So suitable frequency, it should possess some minimum frequency. Then only this photoelectric effect happens. See, simply let us take here, this is metal, this is, let us take sunlight. So sunlight energy is falling on this, so that electron is ejected. So this electron ejected from the surface of the metal is called as what? Photoelectron, because this electron is ejected in photoelectric effect. So this electron which is ejected from the surface of the metal is called as photoelectron. Okay, let us learn some in detail. So let us consider an atom. In an atom, there are different energy levels. Okay. So where this is n is equal to 1, first energy level, second energy level, third energy level, fourth energy level, fifth energy level. There is a space around the nucleus where the energy of the electron is equal to 0. So the place where the energy of the electron is considered to be 0 is called as infinite distance. What is that called as? Infinite distance. Okay. And we know that electron in the energy level has some energy. And the energy of electron in different energy levels will be different. The energy of electrons in different energy levels will be different, not same. Right? So let us take electron in the fifth energy level, for example. It is having a minus something 5 electron volt energy. It is having minus 5 electron volt. And let us take electron in the third orbit. It is having minus 3 electron volt. I'm speaking generally, because if the electron at infinite distance is having zero energy, when it is approaching the atom nucleus, no doubt some energy will be lost. After losing some energy, automatically from zero, if some energy is lost, then automatically it will have minus energy. How much closer it comes to the nucleus, that much amount of energy it will be losing. So more closer it is to the nucleus, less amount of energy it possesses. For example, in the third orbit, it is having a minus 8 electron volt. Okay, and we know that minus 5 is greater than minus 8. More closer the electron to the nucleus, more the energy it will lose. So we have to remember that all the electrons in an atom, especially if they are in different energy levels, they possess different energies. Okay. And ionization energy. What is meant by ionization energy? It is the amount of energy required to remove an electron from the outermost orbit we discussed. That is first ionization energy or ionization enthalpy. So you are removing this electron. That means you are making this electron, for example, it is in the fifth orbit. You are making this electron to move from the fifth orbit to a place where nucleus does not show any effect on this. What is that place where the nucleus does not show any effect on this? That is called as infinite distance, where energy of the electron is equal to 0. So ionization energy can be calculated by E infinity minus E fifth orbit. For example, if it is removed from fifth orbit, that means 0 minus 5 volts, that is equal to plus 5 electron volts. If the electron is having minus 5 electron volts, if an electron is having minus 5 electron volts in a particular energy level, then the ionization will be in plus. That's it. Okay. So why we are speaking? Because here light energy is falling on the surface of the metal. Light energy is falling on the surface of the metal. Based on the energy present in the light, electrons are ejected from the surface of the metal. So this photoelectric effect is explained based on the particle nature of light. What is that? Particle nature of light. It is explained based on the particle nature of light. So what natures do light possess? Both natures, particle nature as well as wave nature. Light possesses both the particle nature as well as wave nature. Okay. So it also explains some law of conservation of energy also. See, light, speaking about the particle nature of light, this light is propagated in the form of small packets of energy. Light is propagated in the form of small packets of energy, or light is radiated in the form of small packets of energy. And Einstein mentioned that these small packets as photons. What are these? Photons. Okay, and you need to remember that there are many electrons in an atom. One electron at a time, what is that? One electron at a time can absorb energy. One electron at a time can absorb energy of one photon. One photon. One electron cannot absorb energy of many photons. So one electron can absorb energy present in one photon at that particular instant. At the same time, it cannot absorb more than one photons. This point you need to remember. Okay. For example, let us take here this is the atom of the metal which is connected to cathode. So alkali metal. In this alkali metal we have electrons in different energy levels. Okay. Different energy levels have different. For example, this electron in the fourth energy level, n is equal to 4, this electron is having minus 5 electron volt energy. Now only we have discussed that if it is having minus 5 electron volt energy, how much energy is required to make this electron move into infinite distance? E infinity is equal to 0. Infinite distance. The amount of energy required for this electron to move into infinite distance is 5 electron volts. 5 electron volts. So that energy, minimum energy required for the electron to be removed from an atom is called as a work function. Here what do we say? This is the energy of the electron in the fourth orbit. For example, what is ionization energy, which is called as 5 electron volt, which is called as a work function. We write it as a W. What is that? We write it as W naught W. What is this? Work function. What is that? Work function. See, there is some minimum energy required for the emission of photoelectrons, and that is called as a threshold energy of work function. What is this called as a work function, or it is also called as a threshold energy. Okay. So first one point which you need to remember is to remove or to eject an electron from an atom, some minimum energy is required. So minimum energy has to be absorbed by that electron. That minimum energy is called as what? Work function. Here from the sunlight, what is that? From the sunlight, it is radiating energy. That radiation is in the form of what? Photons. And one photon can be absorbed by only one electron. Let us consider this photon is having some energy E. E is equal to h nu according to Max Planck's quantum theory. We have already studied that E is equal to h nu. H is constant, E is directly proportional to is directly proportional to frequency of the radiation. If the frequency of the radiation increases, automatical energy increases. So energy is the function of frequency. Depends upon the frequency of this radiation. So what are these packets of energy called as photons according to Einstein? For example, this energy is 4 joules, like 3 joules for example. Each photon is having 3 joules of energy. If this is falling on this electron present on the 4th orbit, how much energy it requires to come out of the atom? It requires 5 electron volts. How much? 5 electron volts. This photon, each photon is having only 3 electron volts. Then will it come out? Coming out means it is moving to a distance where the nucleus does not show any effect on that electron. That means what is that called as infinite distance? What is that called as a infinite distance? So to make this electron to move to infinite distance, how much amount of energy is required? 5 electron volts is required. But how much energy does each photon is having? Only 3 electron volt. So won't this electron absorb that 3 electron volts? Yes, it absorbs. What does it do? It absorbs the electron. It absorbs the photon. It absorbs the photon and it moves to, it does not go to infinite distance. It jumps to excited state. Again, what does it do? It releases the same amount of energy and comes to its original state. That is what happens. It will absorb that 3 electron volt. You may be having doubt that, sir, this electron can absorb 2 photons, 3 plus 3, 6 electron volt. For this electron, energy required to come out is only 5 electron volts. So 6 it can absorb. So that does not happen. Already it is discussed that at that particular instant it can absorb only 1 photon. After absorbing 1 photon, some process happens. If that photon has sufficient energy for this electron to come out, it will come out. If this photon does not have sufficient energy, then it will get excited to higher energy state, again comes to the original state by losing energy. It will not come out. So how much time you go on, or whatever the time you go on, make the radiation to fall on this metal surface, if that does not have sufficient energy means minimum frequency, then the photoelectric effect does not take place. So these photons must possess a sufficient frequency, minimum frequency, so that it will have some minimum energy to make this electron to come out from the metal surface. So that minimum energy is called as a work function. Okay. So here let us increase the frequency. On increasing frequency is increased. If you increase the frequency, what happens? If you increase the frequency, what happens? If you increase the frequency, energy increases. So 3 electron volt, let us convert it into how much? 4 electron volt. Now will the electron come out? Each photon is having 4 electron volt. Will the electron come out? No, because for the electron to come out from this 4th orbit, how much amount of energy is required? 5 electron volt is required. Again increase the frequency, energy is increased. Energy is increased. So let us increase the energy to how much? 5 electron. Does it increase the energy up to 5 electron? Now each photon is having 5 electron volt. and this electron needs 5 electron volt to come out. Now will the electron come out? Yes. The electron will eject from the surface of the metal, but it will not have any kinetic energy. It will not have any kinetic energy. Again, increase the frequency of the photon. Let us convert it into how much? 6 electron volt. How much? 6 electron volt. 6 electron volt. See, it want only 5 electron volt to come out from the atom. But each photon is having how much energy? 6 electron volt. So 5 electron volt it will use for to come out, and the remaining 1 electron volt is converted into kinetic energy. Okay. So 6 electron volt is the energy of the incident radiation. Okay, 6 electron volt. 5 electron volt, 5 electron volt is sufficient for the electron to come out, and the remaining 1 electron volt, what happens? It converts into kinetic energy. So here energy, whatever it is falling on this metal surface, it is used for two purposes. What are those? One is for the electron to come out of the atom, another is converting into kinetic energy. Kinetic energy, this also explains the law of conservation of energy. Okay. Right. So what we are speaking, E is equal to W plus KE. What is E? E is energy of the photon. What is E? Energy of photon or incident radiation. Radiation is being incident on this. What is W? Work function. Work function is also energy. It is also energy. KE is kinetic energy. What is that? Kinetic energy of photoelectron. Kinetic energy of photoelectron. Okay. So now we discussed what? E is equal to W plus K. W plus K. So E is equal to h nu from the Planck's quantum theory. W is also energy. W is also energy. H nu naught plus K. So what is nu here? Nu is frequency of incident radiation. Incident radiation. See? Light energy is being incident on the metal. Light energy frequency. Simply speaking, frequency of the light. The frequency of the photons. What is nu naught? Threshold frequency. What is that called as a threshold frequency? So threshold frequency meaning is minimum frequency required for the electron to come out of the metal surface or to come out of the metal, and that is called as what? Threshold frequency. So nu naught is threshold frequency. So first, what is this? W is equal to h nu. We are speaking nu naught. Why we are speaking nu naught? Because it is a threshold frequency, whereas nu is frequency of the light radiation. So now let us come to kinetic energy. you want kinetic energy, then what you can write? H nu minus H nu naught. This comes. So kinetic energy is equal to H nu minus nu naught. So this is one formula where numerically we can be asked a question. So kinetic energy of the photoelectron, Ke means kinetic energy of the photoelectron, ejected electron in the surface, is given by H nu minus nu naught. So let us derive one more equation. So kinetic energy is equal to H. From the characteristics of light, we have studied that C is equal to nu lambda. What is lambda? Wavelength. Nu is equal to C by lambda. So instead of nu, I can write it as C by lambda. What is C? C is velocity of or speed of light. Speed of light, which is equal to 3 into 10 power 8 meters per second. Okay. Minus. Then here also we are applying nu naught. Nu naught is equal to C by lambda naught. What is that? Nu naught is equal to C by lambda naught. Nu is equal to C by lambda. Nu naught is equal to C by lambda naught. Where lambda is wavelength of incident light, whereas lambda naught is threshold wavelength. What is lambda naught called as? Threshold wavelength. So minimum wavelength required for the electron to come out of the surface, and that is called as what? Threshold wavelength. So kinetic energy is equal to Hc 1 by lambda minus 1 by lambda naught. So kinetic energy is equal to Hc lambda naught minus lambda by lambda into lambda naught. This is one more formula to calculate the kinetic energy of the photoelectron. Kinetic energy of the photoelectron. Okay. Then let us find the formula to calculate the velocity of the photoelectron. So kinetic energy, we know the formula of mv square is equal to Hc into lambda naught minus lambda by lambda into lambda naught. mv, this is v. Then v square, what do we get? V square is equal to 2 Hc by m lambda naught minus lambda by lambda into lambda naught. Okay. Then if you write v, then what do you get? Root over 2 Hc by m into lambda naught minus lambda by lambda into lambda. So this is what v is velocity of photoelectron. Velocity of a photoelectron. What is m? M is mass of this electron or photoelectron. Where h, we know that it is a Planck's constant. Planck's constant, which is equal to 6.626 into 10 power minus 34 joule into second. Okay. So these three expressions or these three formulae we need to remember. One is kinetic energy, this one also. So three formulae are for calculating the kinetic energy of the photoelectron. Another one is calculating the velocity of photoelectron. Okay. So next, coming to intensity, what we are speaking about, intensity of incident radiation, or intensity, which is also called as brightness of light. In other words, it is discussed as number of photons with a particular frequency radiated per unit area per unit time. In simple language, we can say intensity. How can we represent the intensity? We can represent or we can define it as number of photons having a particular frequency radiated from the light per unit area per unit time. That's called as what? Intensity. So let us try to understand how this intensity is being operated in photoelectric effect. So this is metallic surface connected to what? Negative terminal of the battery. So this is what zinc plate, which is connected to positive terminal, where in the middle, what do we have? We have an ammeter which shows the reading whether the electricity is flowing or not. So if we are not focusing light on it, then it does not show any reading. That means the circuit is not completed, and there is no deflection of this, no deflection in ammeter. When light is made to fall on this, metal, automatically, if the electrons are ejected, that means this light should possess some minimum frequency. It should this photon must possess some minimum energy so that the electron comes out from this metallic surface. Then automatically there will be deflection in the ammeter, showing that electricity is passing in the circuit, and you can record how much amount of electricity is passing in the circuit. Okay. So this flow of electrons in the circuit is called as electricity, and due to these electrons, some electricity is being generated. In that way, sunlight energy is converted into electrical energy. Okay. So now we are speaking about intensity. So for example, the electron to come out, how much amount of energy is required? 5 electron volt. Here there are photons falling from the sun. This is sun, sunlight energy. For example, let us take in a particular unit area, how many photons are there? 1, 2, 3, 4, 5 photons are there. Each photon is having 6 electron volt. Now you say, how many electrons will come out from the metallic surface when these 5 photons fall on this metallic surface? So how many photons? 5 photons will come out. So here, when these photons fall on the metallic surface, instantaneously, without any lag, these electrons come out from the metallic surface. There will be no lag. When these photons fall on the metallic surface, electrons absorb this photon energy, comes out very fastly without any lag. That means these photons must possess minimum energy which should be able to eject these electrons from the surface of the metal. So there in this particular area, how many photons are there? 5 photons are there. So these 5 photons energy is absorbed by 5 electrons, and these 5 electrons come out. So these 5 electrons are moving in the circuit due to this five electrons, there will be some electricity generated. Electricity generated. If I increase the intensity, that means I am in that same particular area. Okay, more number of photons, like some 8 photons. How many photons in this? 8 photons. Here 5 photons. Here 5 photons. Here 8 photons. That means I have increased the intensity. Each photon is having again 6 electron volt. So in that same time, how many photons come out? Now, on increasing intensity, intensity is increased. Intensity increasing means number of photons per unit area we have increased, and each photon is having same energy. So on increasing intensity, what is increased? Number of photons, number of electrons ejected increases. Before increasing the intensity, what is the kinetic energy of photoelectron? Before increasing intensity, kinetic energy of photoelectron is 1 electron volt, because each photon is having 6 electron volts. 5 electron volts it will use for the electron to come out, and the remaining 1 electron is converted into kinetic energy. After increasing intensity is increased. Again, now also kinetic energy is how much? 1 electron volt, because each photon is having 6 electron volt. 5 electron volt it will use for the energy to come, electron to come out. The remaining energy, 1 electron volt, is converted into kinetic energy. So before increasing intensity, kinetic energy is same, and after increasing intensity also kinetic energy is same. So kinetic energy of the photoelectron is independent on the intensity. It's independent on the intensity. So that is what the graph is given. In photoelectric effect, the number of photons emitted is proportional to intensity. So that means here you see 5 photons, 5 electrons. 5 photons, 5 electrons. 8 photons, how many electrons comes out? 8 electrons. So number of photoelectrons emitted will increase if you increase the intensity, but frequency, the kinetic energy does not change. See, kinetic energy, increase intensity, kinetic energy remaining same, increasing intensity, kinetic energy remaining same. That means kinetic energy remains constant, or we say that it is independent on the intensity of radiation. Intensity of radiation. What is this kinetic energy of photoelectron? Kinetic energy of photoelectron. So understood, intensity. Intensity means number of photons per unit area per unit time is said to be here intensity. Intensity in physics we have a different definition, but here in chemistry this is the explanation. Okay. Then how does the kinetic energy of photoelectron depends only on the frequency of incident radiation? If the frequency of incident radiation increases, then kinetic energy increases. So let us discuss that. Here we have a metal surface. For the electron to come out, 5 electron volt is required. From here, sun rays is falling, photons are falling. Each photon is having some, how much amount of energy? 3 electron volt, for example. Here this is 0. Okay. Here you are increasing frequency, increasing frequency, increasing frequency. See, E is equal to h nu. E is depending upon frequency. E is equal to h nu naught. H is constant. E is depending upon whom? Threshold frequency. In this say condition, H here, what is this condition? This condition is nu is less than nu naught. 3 electron volt. 3 electron volt means 3 electron volt is proportional to this frequency. If you increase frequency, energy increases. So it is related to this frequency of incident radiation. So here the photon is having 3 electron volt, but work function is 5 electron volt. So how do you relate these two? These two are related as frequency of incident radiation is less than threshold frequency. Now will the electron is ejected? No photoelectricity. What happens? No photoelectrons are ejected. No photoelectrons are ejected. If there is no photoelectron ejected, where will be the kinetic energy? That is what here it is spoken. For example, this is the frequency related to 3 electron volt. Let us consider this is the frequency related to 3 electron volt. Frequency related to 3 electron volt, right? In the same way, now what I am doing is I am increasing the energy of incident radiation. How much I am increasing? I am making it to 4 electron volt. 4 electron volt. The same condition is here again. 4 electron volt. Here we want 5 electron volt. Again the same condition. The electron does not come out. Electron does not come out. If the electron does not come out, will it have any kinetic energy? No kinetic energy. Okay. Again, let us increase it. Increase it up to 5 electron volt. Yes. Now this is a condition where nu is equal to nu naught. Nu is equal to nu naught. So that electron ejected with kinetic energy is equal to 0. Without any kinetic energy, this electron is ejected. Okay. See, this shows nu naught. Is this a nu naught? Is there kinetic energy here? No kinetic energy. No kinetic energy. Now I am increasing this energy to how much? 6 electron volt. So now what is the condition? Nu greater than nu naught. 6 electron volt. This energy is proportional to what? Frequency. More the frequency, more the energy. What is that? More the frequency, more the energy. See, let us take 6 electron volt, frequency will be more. So when nu is greater than nu naught, what will be the condition? Electron is ejected and moving with some kinetic energy. It will have kinetic energy. So now let us take, again if you are increasing frequency, there is some kinetic energy. If you are increasing frequency, kinetic energy increases. If you are increasing frequency, what happens? Kinetic energy increases. Okay. Are you getting this? See, if you make 6 electron volts, so if E is equal to 6 electron volt, kinetic energy is equal to 1 electron volt. If E is equal to 7 electron volts, kinetic energy is equal to 2 electron volt. If E is equal to 8 electron volt, kinetic energy of the photoelectron is 3 electron volt. Hope so you understood. Because threshold energy or work function is same, 5 electron volt. Are you getting this? So kinetic energy versus frequency. What is this frequency of incident radiation? Frequency of incident radiation. So this is kinetic energy of photoelectron. You draw a graph, you will get a graph like this. So for each metal, there is a characteristic minimum frequency, also known as threshold frequency, below which photoelectric effect does not observe. See, this is the condition. Nu less than nu naught. At frequency nu greater than nu naught, then photoelectric effect is observed. If nu is less than nu naught, photoelectricity is not observed. If nu is equal to nu naught, photoelectron ejects from the surface of the metal with kinetic energy is equal to 0. Okay. Next, coming to what is meant by stopping potential. Stopping potential. So already we have seen the setup. This is metal connected to negative terminal of the battery, photoelectric metal, whereas this is another electrode made of something like zinc. This is ammeter. Okay, this is connected to positive. So now photons are falling on the metal, electron comes out, and it is moving with some kinetic energy. It is shown in this ammeter. How much electricity is flowing through the circuit, it is shown in this ammeter. So flow of these electrons in the circuit is called as electricity. The amount of electricity is shown in this ammeter. Okay. Now what you are doing? You are applying some opposite potential at the anode. This is anode. You are applying some opposite potential. When opposite potential is applied, automatically, when some opposite potential is applied, automatically this electron slows down. Again, if you increase some more opposite potential, this electron still slows down. And at a particular opposing potential applied at anode, this electron stops. That potential applied, what is that called as V naught. That potential applied so that the electron kinetic energy is 0. It's called as a stopping potential. So this stopping potential applied at anode so that the kinetic energy of photoelectron becomes 0. Kinetic energy of photoelectron becomes 0. That's called as a stopping potential. We know that, for example, between these 2 points, there is a potential difference of V. If a charged particle like electron is accelerated in this between these 2 points, then the kinetic energy attained by that electron is given by EV. What is that? If a charged particle having charge E, for example electron, is accelerated in a potential difference of V, then kinetic energy is given by that charge into potential difference. Charge into potential difference. So before we have discussed that here we are applying opposite potential or stopping potential. Then kinetic energy of the photoelectron will become EV naught. Okay. Before we have discussed kinetic energy is equal to H nu minus nu naught formula. Equate these two, then what do we get? EV naught is equal to H nu minus nu naught. Okay. What is E? Charge of an electron. V naught, stopping potential. The remaining things you know. H Planck's constant, frequency of incident radiation, threshold frequency. Okay. So basic information regarding photoelectric effect is, what is that basic information? When the photons are falling on this metallic surface, electrons are ejected. Until this light having a minimum frequency or suitable energy fall on the metallic surface, there is no deflection in the emitter, and the emitter does not show because circuit is not completed. When the light fall on the surface of the metal having sufficient energy so that this electron is ejected, and deflection is shown in this emitter, and the emitter shows the amount of current passing in the circuit. Okay. So this is about photoelectric effect. Thank you for watching up to the video, and we shall meet in the next video. Right? Thank you.